This right here, this is primarily an electrician's tool, but that's what it used to be. But more and more HVAC service techs have found the usefulness of this. Sometimes our problem is power. Power on our line voltage or power on our low voltage. This saves me time from trying to search. Come with me, watch. Sometimes if I want to verify if I have line voltage power, I can just touch the wire and then I know that I have voltage. That'll save me some troubleshooting. It'll also pick up my low voltage. Okay, you guys don't know about low voltage yet, do you? We're going to talk about it. That's the control side of our HVAC systems. It's 12 volts, not 120. We're going to talk about the electrical side of these units in our next phase, our next session. But let's stay with the tools right now. This will read, and it's just, I'm trying to see, I don't even know what you call it. That's an conduction electric, okay? So, but at Home Depot, they sell them, or any electrical supply store. They just voltage tester. That's what it is. It's a voltage tester. Just turn it on, touch the wire, and if there's power in that wire, the light will change from green to red, and it'll begin to beep. It'll do that on the line voltage as well as the low voltage. Awesome time saver in our troubleshooting methods. Let's move to the next. This is our PVC tubing cutter, okay? It's the tool that we use. It's like our or our copper tubing cutter, but this one is for PVC. This is actually a coupling to connect PVC. I don't actually want to cut it, but if I continue to squeeze this trigger, it'll tighten that jaw up and it'll cut right through. It's my PVC tubing cutter. We often need it. A lot of the tools that we're dealing with and showing, a lot of them are more so used in installs. As a service tech, install isn't really what you do, but sometimes you need to replace as a service tech. See, if I go to an air conditioning system that isn't working, if it was working, that means the electricity has already been run to it. The refrigeration copper has already been run, and there's already been an inspection. As long as I'm not running new power to that unit, I can change it out as a service provider. In dealing with service, sometimes we're going to have to replace gas furnaces. You know, if an existing gas furnace goes bad in the Washington metropolitan area, and I'm sure the code is pretty close or similar in other jurisdictions, of course you're going to have to figure that out in your jurisdiction. But in Washington, if I do not replace more than 4 foot of gas piping, I don't need a new permit to change out that furnace. And typically, changing out a furnace, you never replace more than 2 foot of the piping for the gas. No permit needed. No permit, no certifications have to be applied. So, while we're dealing with service, I'm going to have to teach you a little bit about install so that you can be a good provider. Let's keep going. These are primarily tools that are used in the sheet metal industry. These are right-handed snips. They're colored in red. They're cut sheet metal in your right hand, but they cut to the left. These are your lefts. They're green. They are made to be used in your left hand, but they cut to the right. You can't cut to the left with lefts. You can't cut to the right with rights. Rights cut to the left, lefts cut to the right. I'm not teaching you guys to be sheet metal workers, but if you go on a job and you find the existing A coil has a leak in it and cannot be repaired, its only fix is to be replaced. In order to do that, you very well may have to make some adjustments to the ductwork. Now, for that, I'm ultimately going to recommend in the beginning that as you get into the industry, you make friends with other tradesmen that you meet in supply houses. Get their phone numbers. Find out guys that do ductwork. And when you have jobs where you have to change out existing A coil and you have to alter the duct, pay that individual to do a part of the job, but watch him so that you can learn. Now, I'm not going to teach you guys to be sheet metal workers, but I am going to demonstrate the use of these tools on some metal so that you at least know what they're for, what they do, and how they can be used. All right? These are called tongues. They're tongues. Their design is to grab flat metal and bend it. You can bend, typically they're used for bending what is called drive ears on the ductwork. That is the way you connect ductwork. You use slips and drives. That's not a part of service, but if you have to change out an existing gas furnace that is tied in to an existing duct system, you're going to have to alter that ductwork to some degree. So I'm going to give you a brief illustration of how to use these zones, how to use these rights, and how to use these lefts. But you're probably going to need to find some sister companies that you can grow with as you figure it out. And when they're doing the ductwork, watch them so that you can do it the next time. All right? All right. I'm only going to hope that all of you out there are familiar with your tape measure. We often need it. We have to make measurements. We have to measure the length of our copper, the length of our ductwork, the length of our tubing, our refrigeration tubing. We need to know the size of the ducts that are tied into our unit. If we need to replace a unit, we need to know the width of that unit so that we can buy a unit that is an exact replacement. That's the best way to keep from doing ductwork. Normally, I take the measurement of the existing coil, its width, its length, and its height. And then I call different vendors and I find one that has a coil with those same dimensions. Then I don't have to alter the ductwork. I can take the existing coil out, I can put the new coil back and tie it right back into the exact duct that's there. Same thing with gas furnaces, same thing with air conditioners. It's, you know, I have accounts and relationships with almost every HVAC manufacturing company in this region. You're going to need to establish relationships. Most of them, once, if you use this to go into business for yourself, most of them, all you need is a business card in your name, and they will allow you to open a cash account. You will need your CFC certification card. I'm going to work with you and help you get that. But you can take a business card to most of the vendors, R.E. Michaels, T-Stat, Lyle & Conklin, Airco, Carrier, Tribbles, whatever companies in your area, Ferguson's. You can go in with a business card, and most of them will open you a cash-only account. Well, for beginning business, that's all you need. You don't want to get yourself extended out with a lot of credit. Vendor customers pay for the equipment. Let them give you a deposit in advance so you can go buy the equipment. Pay for it with a cash account, and the more vendors you have relationship with, you can more than likely find exact replacements for whatever job you're doing. Then there are very few alterations that need to be made. I'm going to make you guys service techs. A part of that has to teach you to replace compressors, complete outdoor air conditioners, complete outdoor heat pumps, complete indoor A coils, as well as complete indoor gas furnaces. Because sometimes as a service tech, the only option for the resident is to replace. So I got to teach you some of that as well. This is going to be an awesome class. But don't forget what I said in the beginning. You got to do your part. You got to watch these videos. You got to make notes. You got to go back and regurgitate those notes. Listen to them, the tapes, more than once. You got to work with me. And if you work with me and you do your part, I assure you, you're going to do wonderful coming out of this class. Let's keep moving. This is my wire strippers, okay? It strips a multitude of different size wires. If you look at it, you'll find up at the top, there are holes and they're different thicknesses. That's for different gauges of wire. As you look at the bottom, you have different configurations. That's for crimping different wires. And also at the top, at this area, is for cutting different wires. We have to strip our thermostat wires. We have to strip our line voltage wire. Sometimes we have to repair wires, put new wire spades on. A wire spade that's these. For different systems, different applications, you have to connect to the system with spades that fit onto certain plugs in the unit. And to do that, if the wire has burnt or gotten broken and you need to replace it, you need to get your wire inside this shaft here, this little hole, get your wire in there, and then you need to crimp to tighten the metal band around the wire to give it a good tight stretch so that you can connect the wire to that spade to plug it on to different spades within the unit. While I know this seems foreign right now, that illustration really may not have made a lot of sense. But throughout the class, we're going to hook up thermostats, we're going to strip the wire, we're going to add spades, we're going to connect. I'm going to show you how to use this tool, and I'm going to show you what it does and the valuableness of it. It's my wire strippers, must have. Our level. I don't know how many of you are familiar with a level, but it will read level on a horizontal, it'll read level on a vertical, and it's about professionalism. Sometimes we have to install our thermostats on the wall, and we want to ensure that it's level, that it's not cocked, that it doesn't look like my 3-year-old daughter put it up there, because we're professionals. So sometimes you need a level to ensure what you're installing is straight, it's plumb, and it looks like a mechanic did it, not Harry Homeowner. So levels are an important tool for the quality of work that you want to provide. Okay? This is a torpedo level. I have 2-foot levels. I even have a 4-foot level. But that's when I was doing total installs. But for service, I only recommend the torpedo level. That's what you need. This is a flaring tool. It is a flaring tool and also a swedging tool. At the moment, you don't know what either of those statements mean, but by the end of the class, you will. This tool allows me to hook to different size coppers, no matter which size it is. I've got a size opening for it. And once I connect it, I can use, well, give me a minute. It's just being difficult tonight. But we're going to get it. Now, once I tighten that in, I can then take this, hook it on. I need to loosen it up a little bit, back it up, so that, why is it so tight? It should never be that tight. But I can hook this on, and it's still got to loosen up some. And as I go down in it, I can get it down far enough to get my connection made to where I'm connected on the copper with my nose going into the copper. Now, as I tighten this, what's going to happen, it's going to flare that copper. And that is used in what we call flare nut connections, okay? This all still seems a little strange to you, but as the class goes on, I'm going to show you a flare nut. I'm going to show you, once you get that end of that copper flared, how there are connecting pieces that will connect, and I don't have to braze the copper. See, there's several different ways that we can connect our copper. We can use flare nuts, and then we don't have to put heat on it. We don't have to put a torch on it. We don't have to braze it. Or we can use this same tool, change the head, and that will allow me to flare the copper in order to stick another piece of copper of the same size inside of, okay? One of the other ways that we use to connect our copper. Once I get that new head on, then I could take the copper, hook it in here, and I could force this into that copper. And what it'll do, let's see what it'll do. Need to back that up. Now, I want to put this back on here, but I need it to stick out a little further this time than what I did when I flared it. But we're going to go over this again. We're going to actually put some nuts on it, and I'm going to show you the different ways that we connect our copper. Okay? Now that didn't go back far enough. I'll get it back a little further so we can get in there. Come on, Baba. Isn't it amazing how when you want to show something, nothing wants to work right? Okay, but now what I can do is I can keep turning that, and what it'll do, it'll flare that copper out. Well, not flare it, but it'll swedge it. Swedging is opening the copper up to a point the exact same size copper can now go inside of it. And once I get it flared far enough back, now I can take another piece of copper of the same size. I can put it inside of itself. Boom. Now that copper is in this copper, and then I can use a torch and my brazing rod, which is a common method that we use for connecting copper. I can braze this with heat and brazing rod and make a permanent connection that will never leak Freon, will never leak. It'll be there for the life of the system. One method of connecting our copper is to swedge, stick the same size copper inside of itself and braze it. Another form, and I don't have a flare nut here with me tonight, but I'll show you one. We flare this, it gets a nut outside of it, and then another nut that's beveled that fits right in that seam, and when you tighten it up with those channel locks that I was showing you earlier, it will seal and give a permanent connection that will never leak, and it'll last for the life of the system. There's a couple other ways that we connect our copper, but I'm going to show you all of them. Because as a service tech, you may have to replace an outdoor compressor because that's what failed on the system. You have to sweat that compressor out, which is to use a torch with flame and get that copper disconnected, and then you have to put the copper back into the new compressor, and you got to torch and flare it. And sweat it back in. When I say sweat, I mean using a torch to melt our brazing rod on the connection to seal it. It's called sweating. We're going to go over that now. That's going to take some practice. I'm going to show you how to do it. But in the beginning, B tanks are very expensive. The turbo torch kit that goes with the B tank is very expensive. Probably about $500 for the complete set. Nitrogen, $250 for the tank, $150 for the regulator that will hook your gauges to the tank. Some of your change out work in the beginning until you've made some money. As you go to vendors, you may need to find individuals that's working for other companies, get their phone number, talk to them, make a friend, have them work with you on some of your jobs that you can use some of their more expensive tools until you make enough money to buy those tools for yourself. We're going to learn it all though, okay? Let's move on. Okay, the convenience and the neatness of swedging is I can connect two pieces of copper with only one braze connection. Every braze connection is a potential leak. None of us are perfect. I am pretty good at brazing, and for the most part, I don't have a lot of leaks. But one of the reasons is I use the proper tool to cut down my risk, okay? Now I don't have this is a coupling. It's just a piece of pipe that is larger, and let's use this 3/4 coupling that goes over, and actually I don't have the right couplings here right now for the pipe, but for every size copper that we have, you have couplings, you have elbows. For every size copper, we have elbows, but if I use an elbow, I have to braze this in and I have to braze this in. That's two braze connections, potential for two leaks. If I use a coupling, then I have to braze this side and I have to braze the other side. Two braze connections, potential two leaks, two potential leak sources. But if I swedge the copper and then I connect it, I only have one braze connection, limiting the amount of leaks that I could have. Now, I could use an elbow on this copper. I do have the right size elbow. I could use this elbow to turn, but again, now I have two braze connections, one at this end and one at the copper going in this end. Or I could use my tubing bender. Showed you this earlier, but let's really understand the convenience of why you would want to use a tubing bender as opposed to using an elbow, okay? When I use the elbow, like I said, I got two connections. But if I wanted to turn my copper in a particular direction and I wanted to minimize the amount of braze connections that I have, then I can use a tubing bender and still get, I want to set it on the right settings because each of these dials have the proper size connection of copper, the proper size copper. If I use this big side, which is for 3/8, and I use it on this small 5/8 copper, it wouldn't bend properly. It would crimp the copper as opposed to making a nice smooth connection. So by using my tubing bender to redirect my copper, I have no braze connections. much better to ensure I have no leaks. You know, warranty is deadly. It eats up your profit. So, if when you install, one of the things I always teach all of my employees and all of my teachers and my students, whatever you do it to the best of your ability. If the system is installed properly, you can go through your full 1 year warranty without ever having to go back and make a repair. But if you have a leak and 3 months after or 2 weeks after they start the system, it's not working because it's low on Freon, because you use a bunch of elbows, you use a bunch of couplings, and you had no solid copper, then it's a very good chance you're going to have a leak. As thorough as I'm going over this part of installation, that's how thorough I'm going to be in every aspect of this class. I'm going to make sure you have the best understanding, the best knowledge of how to use the tools, how the components work. We are going to create service technicians bona fide. Okay? Let's keep going. All right. What we have here now is we got a couple different sets of Allen keys. Okay? Some of you may know what an Allen key is, but some nuts aren't Phillip head, as we shown the different screwdrivers. They're not flat head. They're not 5/16. They're Allen keys. And you have to have the proper Allen key in order to get to those nuts and get them out. So I have a couple of different, and actually I got 2 or 3 more sets of Allen keys on my truck, because some systems that we work on, the Allen keys that they use are metric. And then you have to have a metric Allen key set. But then some of them use American measurements. And then you have to have American Allen key set. Some systems, as we work on them, we find we need smaller than what's on this particular set. Sometimes we find we need larger than what's on this particular set. But as you get into the career, as you move, you're going to find different tools that you need that at the moment you may not have. You'll have no choice at that time but to go buy that tool. Most of the tools that I have 3 or 4 of the same tool. I got 2 or 3 of them on my truck at a time. You misplace tools, you lose tools. I'm going to talk about tool bags, the one I like, because it makes it a lot easier to keep up with my tools. They're pretty expensive. So you want a method of tracking them that you're not leaving them on jobs and then have to repurchase them again. Okay. But you are going to need several different sets of Allen keys. As the class goes on, we begin to take things apart. I'm going to show you areas where you need these and how to use them, okay? These are different than my channel locks. They're different than the pipe wrench. These are called vice grips. What makes them different is they have an adjustable nut at the back of them that allows them to adjust to different sizes. So they are vice grips, which means if you adjust them to the proper size of whatever nut you're dealing with, you can, too tight, loosen a little more, you can lock it. and now it's got that screw. That screw ain't going nowhere. It's locked in, and then I can manipulate different situations, different circumstances. It's always good to have at least one pair of vice grips, because that's what they do. They vice and lock, and once they get hold, they're not going to let go. Okay. Uh, Good pair of vice grips, always good to have. This right here, a lot of you use it for your barbecue grills. It's just a torch, basically, a long cigarette lighter. But sometimes on older systems, they have what's called a standing pallet. Sometimes that pallet goes out. That pallet is normally deep in the heat exchanger. We're going to go over that. But in that event, you need something that will reach into that unit and light that pallet without getting your fingers singed off. Okay. So it's just a striker. Get them at Home Depot, most hardware stores. Um, Definitely our vendors do carry them. It doesn't matter make or model. It's just an extended cigarette lighter, but it's useful when you have to relight pallets. Must have tool. Then you have your conventional needle nose pliers. They have very small jaws at the end. They fit in tight spaces, and they're useful at times. We run into a lot of situations, and most of the time, what helps us the best is having the proper tool for the job. That's one of the reasons why I'm taking this much time on tools. But I intend to be as thorough in every segment of this course. I want to make sure you know the tools, what they do, how to use them, and then as you get into the industry, you can determine which ones you actually want to purchase. But you have a much better understanding if you've seen them all in effect. I put a post out recently where I talked about understanding the systems that we work on and the components within them. And 90% of the job is over. The other 10% is having the proper tools to do the job that you need to do. As the industry is growing, different manufacturers want to make their system different from everyone else's. We've used 5/16 and quarter-inch nuts with the square rectangular head that fits the 5/16 nut driver or the quarter-inch nut driver for the last 30 years that I've been doing this. It's been an industry standard. But of late, I've found vendors are now using a multitude of different screw heads in their system. Why? Just making things different, but it makes their systems unique. So you will find that you need these star sets. You'll find that you need these carpenters normally use these square head adapters, but you have your 3/8 nut driver, your 5/16 nut driver, your quarter-inch nut driver. You have a variety of attachments in these kits that ensure when you get on the job, whatever nuts are being used, you have the tool needed to extract whatever part you're trying to extract. It industry vendors are making it rough on us. They're changing things in order to make their system different from everyone else's. I don't know why. So what? You use star head screws. Everybody else use 516. Uh, but that's what they're doing. So these, pick them up at Home Depot. Nice set to have on your truck. To, time is money. And when you get on the job and you don't have the tool that you need to expedite the repair, you're costing yourself money. So the better arrangement of tools you have, the better technician you're going to be. Remember, I'm making self-proprietors. I am teaching you to be in business for yourself. A part of that is understanding time management. The better tools you have, the more effective you're going to be. Even if you get a job in the industry and you're the fastest tech in the company, they're going to pay you a lot more money than they pay that other guy because he don't have the tools and he's fumbling trying to take things out with the improper tool. Get the tools. As you make money, invest money in yourself, and it's going to make you more money. Let's move on. All right. Some of these tools you're going to be able to get by without in the beginning. Okay. But most of our vendors today are putting their systems with charges predicated on ounces and pounds. So they want you to weigh the Freon in to the factory charge. Mostly you find it on commercial systems, but it is moving into the residential systems as well. So you need a scale. Now, this scale is used for my Freon. The first thing I want to do is I want to zero it out. And then what you want to do is put your Freon on the scale. Now to tell you how much Freon weight you have in your tank. And if the system calls for 1.3 ounces, then you start charging the system. And as you begin to charge the system, this will register the weight of Freon that you take out of the can. So you just have to subtract what you want to put in from the weight of what you have. Now, of course, our tank of Freon would be a great deal heavier than what we have here. So if your tank starts with 25 pounds, but you know the system needs 3 pounds, 4 ounces, then you simply subtract the 3 pounds, 4 ounces from the 25 pounds of your can. Okay. This can also be zeroed again, and it will charge the, huh? Not right now. I'm gonna get it.
I'm sorry.
We still on?
Yeah, when you said tank, I thought she was.
No, your tank of Freon. You can edit this part out. I can pick up and start again.
Yeah, just start from your last one.
Okay. You can also zero it again. And now, as you let Freon out of the can, it'll show you how much weight you put in. So it'll show you how much Freon you're putting in as you charge it It'll show 3 pounds, 4 pounds, 5 pounds, just depending on whether you zero it to weigh what's in the can and you subtract, or you zero it again and it will not show the weight of the can, but it'll show how much weight comes out of the can. It's a charging tool for mostly residential systems, mostly commercial systems, but it's now moving into residential systems. When you do a change out, sometimes you need to look at the data plate on the unit and it'll tell you what the factory charge is, and that's how much Freon you want to put in the system. But we're going to teach you to charge by superheat, by subcooling, and one other method that I'll show you rather than tell you about. But we're going to understand all the different ways of charging a system. I'm going to give you all that you need. Can I get a show of hands? How many of you know what this is? Simple shop vac. It sucks dirt and it also sucks up water. It's a valuable tool when we're cleaning coils, doing preventive maintenance. We need a shop vac. Okay? The shop vac will allow you to extract water. It'll also allow you to extract dirt from the heat exchanger when you're cleaning it. When we clean coils, sometimes we need to extract the excess bubbles that come from the coil cleaner to keep them out of the furnace. So shop vacs are a valuable tool that we often use, okay? And with the shop vac, sometimes it can be used to clear a clogged condensate drain line. I'm going to show you how to do that. We have our swoosh kit, one method. Sometimes our shop vac can be a valuable tool for clearing condensate drain clogs. All right? Shop vac, not expensive. I think this is about 89 bucks at Home Depot. Great tool to have on your truck. This is a vacuum pump. Okay? It is used whenever we open a refrigeration system up, we have to use a vacuum pump in order to remove all moisture from the system. Okay? Moisture is an enemy of compressors. So before I can put Freon into a system that is void of Freon, I must use my vacuum pump in order to remove all of the air that is in the lines. If there's no Freon in the air, in the lines, then they're going to be full of air, because in our environment, no space can be void. It's not possible, if all the Freon is out, that line didn't fill with air. And air, of course, carries moisture. The moisture that is within the air in the refrigeration lines will destroy the compressor. So, in order to prevent it, you must have a vacuum pump on your truck. This is a real handy one. It's inexpensive, but I bought it because of its weight. Sometimes the units that we work on are in attics, maybe on a roof. You've got to go up an extension ladder, you got to climb up a ladder, and You don't, the lighter the tool, the better the tool. So my option was this particular model, which, crap, I've had it so long, the name is gone off of it. I don't even remember what model it is. This is actually off of my truck. I've had it on my truck for about 8 years now. They're very durable, very reliable. And when you purchase a vacuum pump, I would not ever purchase one from a pawn shop. I would only purchase it new because the way a vacuum pump works is you hook your gauges. Remember when we were talking about the gauges and I said the yellow hose? The yellow hose hooks to the vacuum pump. And then you hook your red and your blue line to your air conditioner system as normal. The blue is the suction side. The blue is the low side. The blue is the thicker of the two coppers. The red is the high side. The red is the liquid side. The red is the thinner of the two coppers. Got to remember that so that you know when you take your gauges, which hose hooks to what. But as you turn on your vacuum pump, it begins to suck the air out of the system. It will get down to 30 microns on your gauges. On the suction side, it'll get to 30 microns, which is below zero. The liquid side only goes to zero. But at 30 microns, what has happened is you have created a negative pressure that creates a boiling effect within the moisture within the lines. Now you have to let the pump run until it removes all the moisture. But this pump can come on, it can run, and if you feel the hose, you feel the suction, but the vacuum pump isn't any good because it will not reach the negative micron level that you need. But a lot of individuals sell vacuum pumps to pawn stores when they no longer work, but they still run. And the tenant at the pawn shop don't know how to determine whether that's a good vacuum pump or not. So don't ever buy a vacuum pump from a pawn shop. Although they're expensive, you must buy it new. And you run some service, and as you make money, you must invest money in your trade. If you take jobs with companies, it's been a long time since I've worked for a company, but at Christian Mechanical Services, all of the major tools, the vacuum pump, the gauge, the scale for weighing the freon in, the B tank, the recovery tank, the nitrogen, all of that was material that was on the truck. All you had to have is your personal hand tools. I believe that has not changed within the industry. But if you're going to work for yourself, you're going to need these tools down the road. Okay? Vacuum pump. And with the vacuum pump, what I have is this plug adapter. Okay? This allows me not to run an extension cord if there's no receptacle outside near the air conditioning unit. A lot of times, most people don't have a power receptacle near their air conditioning unit. And if the unit is in the backyard, if the unit's on the roof, I got to run an extension cord from the house all the way out. Or with this and these alligator clamps, I can go into the electrical disconnect at the unit, plug in, and get power to feed my vacuum pump right where the unit is. It's a time saving tool. I'm going to show you how to use it, teach you how to use it so that you too can save time on any call where you need power. All right. This tool here has saved me so much time and also saved me so many of these 3 amp fuses. Well, not every unit, 98% of every unit we work on has one of these fuses on the circuit board. And sometimes that's the whole problem. I've gone to so many homes where this fuse was bad. I replaced the fuse and the system's working wonderful. I charged the people $105 for a service call because I came out and I charged them $6 for the fuse. My total invoice was $111. I was in their house for 15 minutes. These fuses, I get a box of 6 for about $2. So I sell them $6 each. But sometimes they fail not because they're old. They fail because something has shorted out in the system. And every time you turn the system on, the fuse blows. So while you're trying to diagnose and trace that short, you keep putting fuses in. You done used 12 fuses and you still ain't figured the problem out yet. But I can put this in. And just like the spades that's on the bottom of my fuse, just like those spades, that would allow me to plug the fuse in. Yeah, excuse me, we have technical difficulty with one of our lights, but it's been taken care of. But those spades plug into connectors on the circuit board. I can move the fuse, and these spades are identical to these spades. So I can take the fuse out, plug this in, and it'll simply keep tripping. And so rather than keep blowing fuses, because I plug this in, and when it fuse trips, it trips this. And that gives me an opportunity to trace the short without burning up all of my fuses that I have on the truck. It costs about 28 bucks. It's a valuable tool to have, okay? Along with this, you often want to have alligator clamps, okay? These you can buy for about $6. You get about 8 of them in a pack, all different colors. You get red, you get blue, you get green and yellow and black, white. And what they do is they allow you to test things, bypass certain elements of the system. If I think I have a bad flame rollout switch, I can jump from one side to the other and verify was that the problem. I can jump out my pressure switch. I can bypass things on the circuit board because I have alligator clamps that allow me to bypass certain elements of the system. Now, that's a part of the understanding that I keep talking about. As I give you an understanding of all the components in the unit, how they work, what they do, you're going to understand what you can jump out, what you can bypass, how to jump it out, and how to bypass it.
Lay
You
them all
know,
side by side and
huh?
lay them all side by side out. Talk about each one.
Okay. So remember, this is basically a resettable fuse. It resets, so it allows me to trace, troubleshoot without continuously putting new fuses in. If there's a short in the system, every time you turn it on, it's going to blow the fuse until you find that short. By using this, I can trace the short and not have to keep replacing fuses. The alligator clamp allows me to bypass certain devices within the system, allows me to jump certain devices so that as a part of my troubleshooting, I can determine where the problem is. Again, it's about understanding. Most of the time, I can walk up to a unit, turn it off, turn it back on, and the unit tells me what the problem is. I use things like this alligator clamp to ensure that the diagnosis that I came up with was correct. If I believe that the flame rollout switch was the problem and I jump the flame rollout switch, then the system should run. It should work. Now I have proven that my theory was correct. This is about understanding. This isn't about going to school for 30 years. It's about completing this course, doing your due diligence, and understanding how these systems work so that you can diagnose them. Our next tool, all right, if I'm doing an install, if I'm doing a change out, I went to a system today and the outdoor unit had caught on fire. The family was barbecuing on the back grill. Grill fell over, caught, set a fire, burnt up the outdoor unit, burnt up, melted the refrigeration lines going to the indoor unit. So I've got to replace the refrigeration lines from the indoor unit to the outdoor unit. I got to replace the indoor evaporator coil, and I have to replace the outdoor condensing unit. $5,800. The material cost me 27. It's going to take a day to get the work done. Okay? I'm going to come out pretty good. But to do it, I have to run new copper line sets. Okay? So what this is, it's a tubing bender so that I can take my copper and I can mold it to fit in different situations. Okay? Um, I can mold it, got to turn it over, get the right line set size. Now, if I'm dealing with 1/2 inch copper, I can set this on 1/2 inch and I can use this. This is a short piece of copper. This is a short piece of copper, and my tool is very cold. There's no heat in it. This might not work real good right now, but this is a tubing bender. And so I can put 90s in my copper without using an elbow, because an elbow has to be brazed on this side and an elbow has to be brazed on this side. That's a potential leak. That's 2 potential leaks. That's solid copper. There's no possibility of a leak. So I can use this tubing bender and I can fit my copper in almost any application. I can bend it, whatever size it is, based on the different heads. I can use this to manipulate my copper to make my installation a great deal easier and cost a great deal less time. Okay? Tubing benders, you will probably be able to get by without it for quite some time. But as you learn, as you grow, as your business grows, you're going to need tools like this to demonstrate the level of quality of work that you do. Proper tools make for excellent jobs. So it's another tool that I am going to recommend that as you grow, put one on your truck. It just makes you look like the professional that you are going to be. Okay? Tubing bender. And they're made by a multitude of different companies. You can look at them in different vendors. They will let you open the box, look at them. They will talk to you and explain to you that system, how it works, what they call it. And this just happens to be the one that I selected, which I have 3 of them, all by different manufacturers. It's which one was available at the supply store that I was at. They all do the same thing. They all pretty much work the same. It's not that big of a deal. Which, all right, this is my nitrogen set, okay? Unfortunately, this on my truck, been there for, I've had this regulator probably for about 10 years. One of my gauges is busted. Not a big deal, because when I use my nitrogen, I hook my gauges up, and now my gauges will read the pressure that's in the tank. One gauge tells me the pressure in the tank. The other gauge tells me the pressure that I put in the system. Fortunate for me, the gauge that reads the pressure in the tank, it's still good. The one that reads the pressure in the system, that's the one that bumped around in my truck and got broken. But once I hooked my nitrogen up to the system, I would still have my red hooked to the liquid line on the air conditioner. I would have my blue hooked to the suction line on my air conditioner. And then when I turn on my gauge, it will tell me, let's see, the level of Freon that I'm putting in the system. If I open the right one, it'll tell me the level of Freon that I'm putting in the system. You should have saw the gauge move just okay? And my finger can't hold all the pressure that's in the can. But this nitrogen, and it has a regulator that, well, let's cut it off, cut the can back off. And the regulator is sold separately from the tank. Now, you buy the tank one time. The tank's gonna cost you about $250. But then you never have to buy the tank again. When the tank is empty, you take it back to your vendor and you trade it in for a full tank. And right now they're charging about $22 for a replacement tank. This comes with 2,500 PSI of nitrogen pressure. I typically use about 300 PSI per installation. So one tank will carry me pretty far, and it only costs $22. And if I use it mostly for leak tests, if I come to your house and your system has no Freon in it, I am bound by law to find that leak and repair it before I put more Freon in. Because we know EPA says Freon is destroying the atmosphere and we can't release it anymore. So if your system is low on Freon, I cannot put new Freon in unless I find and repair that leak. In order to do that, often, most cases, is easily taken care of by hooking my regulator up to my nitrogen tank, hooking my gauges to my system, and now I can fill that system with 300 PSI. I can fill it with more, but normally at 300 PSI, wherever that leak at, I'm gonna hear it. 300 PSI inside a small copper tube. If there's a pinhole, you're gonna hear that air. But even if you don't hear it, you add a little Freon. It's acceptable by the EPA. It's called purging. You add a little bit of Freon, and then you use your leak detector that I illustrated earlier. That leak detector will guide you to where that Freon is leaking out at. Most of the time you're gonna hear it, and you run your hand along it, you'll find that leak. But if you can't find it, it's very small, use your leak detector and it will guide you to that leak. So that's one of the main things we do with nitrogen is we leak test by hooking our gauges up to the unit, and then I can charge the unit with nitrogen so that I can leak test. All right? That's our nitrogen and the use of our nitrogen. We are going to connect a heat pump to this system, and you're going to help me. We're going to run the copper. We're going to set the outdoor unit. We're going to vacuum it down. We're going to charge it with Freon, and then we're going to turn it on. And you're going to help me do that, okay? We're going to go over the gas furnace. We're going to show the application of these tools within this unit as we begin to take it apart and put it back together again. We're going to show you all the potential failures We're going to look at a 80 plus gas furnace, and we're going to look at a 90 plus gas furnace. And we're going to teach you how to determine which is which based on the flue on the different units. This flue pipe is metal. That flue pipe is plastic, PVC. We're going to understand that 90 plus furnace. We're going to understand this 80 plus furnace. We're going to understand this heat pump along with its electric element and everything about each of these units. And just like I can diagnose a large volume of problems by phone, by simply asking some questions, you're going to be able to do that also. Because when you know all the components in the system, you know what they do. When the client tells you what their system does, you're going to know what it didn't do, and you're going to know what the problem is before you arrive on site. This isn't rocket science. It's very simple. You just need someone willing to give you the understanding. I'm that guy. Let's look at the brazing connection. All right, let's talk about what you need in order to do a braze connection on your copper, okay? First off, you need a coupling, a way to connect the two pieces of copper, okay? As I told you, coupling slightly bigger than the copper. Now, the copper goes into the coupling. So I'll push the copper in. Now, the purpose of using the coupling is so that you can couple something together. So I'm connecting more than one piece. So we want to get the other side, or that side, okay, into the copper, okay? Now what you need is you need a brazing rod. Of course, we talked about the B tank, which is your your acetylene and a B tank. Some people use actual torches, which is different, acetylene and oxygen. I prefer the B tank, all right? This is my brazing rod. Now, I need heat. So, because I need to melt the brazing rod to fuse the two pieces of copper together. Now, there is a method to brazing, okay? Heat is very important, the use of your heat. The brazing rod, as you get the pipe hot, the rod, the alloy in this rod will follow the heat. So you've got to use the heat to draw the solder or the brazing rod where you want it, which is draw it into the connection, all right? When I start heating my pipe, I'm going to start with my torch on an angle. I have to heat the pipe, but while I'm heating the pipe, I want the flame to run off onto my coupling. Now this pipe has to get cherry red. It has to get cherry red in order to be hot enough to melt the brazing rod. But once it gets cherry red, I want to reposition my torch so that I now move my flame onto the coupling so that the brazing rod will draw into the coupling because it's drawing to the heat. It's also important to learn to utilize your heat. You want your brazing rod to melt, but you don't want it to run like water. Too much heat, it'll run too fast. And while it may seal up today, you don't have a leak when you pressure test, but you have a weak connection and it won't be long before it's going to be a leak. So utilizing your torch is a skill and it comes with practice. I can teach you the method, but you are going to have to get practice working on it in order to perfect it. All right? Let's go over that method that I was talking about. All right. So we're going to,
Wanna get a little closer?
if you can see it from where you are, just zoom a little bit, you're good. My voice is probably going to get a little faint because the torch is very loud. It's a lot of pressure of the acetylene coming out at a force, and so it's going to get loud. All right, but as I said, I'm heating the copper, but I have my flame running onto the coupling so that I'm actually heating both at the same time with the most of my heat on the copper that goes into the coupling. So as it begins to get hot, I can move my torch around a little bit because you can put all that heat in one spot and literally burn a hole in the copper. So you want to rotate it. Now you can see your brazing rod is ready to melt. Now I want to move the flame while I'm still keeping both pieces hot. But now as I go around, you can see that brazing is running into that connection. Sometimes you may want to angle your brazing rod so that you can easily reach the bottom of the connection. Okay? Now that is a pretty good connection. I'm pretty sure I don't have a leak there. But before you move it, you want to give that solder, that brazing rod, a chance to cool. Also, I now have to connect the other side. So what I would typically do, because I don't want callbacks, I want to make sure my job is done to the best of my ability. So what I do is I put a wet rag back here about 3 inches away from where I'm working to ensure that I don't re-melt this connection. But you can do it without the wet rag, but here we go. Let's braze the other side. The same technique. I'm going to heat the copper until it gets hot enough to melt the brazing rod. But at the same time that I'm heating the copper, I'm heating the coupling. Then I'm going to move my heat to the coupling so that as I apply the brazing rod, the heat will draw the brazing rod into the connection, okay? I don't want the pipe too hot. You will have to kind of see when the brazing rod is running too fast, it's running like water, back your heat up so that you're not applying as much, so that you get a good coat of the brazing without it running too fast. This takes a little bit of technique, and that technique has to be learned, has to be practiced. But if you follow these principles, this theory, practice, follow this application as I'm teaching it, it won't take you long and you'll be good at it. Let's do our second connection. I'm going to heat the copper, but I'm letting my heat run to the connection, the coupling as well. I'm going to roll my heat around so that I can kind of ensure that I'm heating the copper evenly all the way around. So the copper will begin to change color. And as it begins to change color, I know that it's ready to melt my braid. Now, I want to move the heat to the coupling. And I'm going to go around again. I'm going to put a little angle on it so that I can get to the bottom without bending down, without getting on my knees. I'll just go over one more time for assurance. That's a good connection. I am certain that connection will hold. I will never have a leak at that connection because of the procedure that I follow. Okay? We're going to talk about when you're brazing, how you would use nitrogen to assist you in your brazing format throughout the project. I'm going to show you, let this copper cool off a little bit. Okay. Now, what I'm going to show you is when I tap this down, watch the table here. Okay. I did a better job than I thought because I'm not getting that flaking into, see the black stuff that's falling down? That there is the carbon that comes from heating the copper. And just like it's outside, it's also, some of it is on the inside. Okay, I don't know if you can see that flaking falling. Okay, that has the potential of damaging your system. It can clog up your orifice. It can, in large volumes, hurt the compressor. The way you prevent that is while you're brazing, you always run a minute amount of nitrogen through the copper while you're brazing. I'm going to teach you that also, but because this is open copper, it's not connected to anything, there's no way for me to hook my brazing up to it right now. But when we tie in our air conditioner to this existing furnace, at that time, I will show you how to apply nitrogen to the copper as you braze it, and that will minimize the level of flaking, the carbon buildup inside the copper. I'm going to be very thorough in everything that I teach you. Okay? Let's go to the next tool. All right. One of the other functions of my multimeter, my amp probe, is I can check for power. So if I have components that are losing power, I can use my amp probe in order to trace that power. We're going to look at my pressure switch right here now, okay? Now, as I check my pressure switch, I'm going to look for power on the two different legs, okay? I've got two legs on my pressure switch. When the circuit board sends power to the induced strap fan motor, it's also simultaneously going to send power to the pressure switch. And it's going to wait for that power to come back to the circuit board in order to prove that the induced strap fan motor actually served its purpose. So, what we need to do, I'm going to shut the unit off. and then I'm going to turn, well, it's starting back up right now. So right now, if I look at my amp probe, I'll see that I have, if I get a good connection, I'll see, oh my God, that I have power coming in. And if I look at the other leg, I have power going out. Okay? In doing that, I'm using my black lead as my ground. I'm using my red lead to trace the power. As we're using our amp probe, one of the important things is I'm going to have to make sure you understand what is a switch. This is a switch. So, because it's a switch, I cannot check it with both leads touching it. If I put both leads on it and I look at my amp probe, I see that I have double zeros. Because this is not a device. It does not take 24 volts to activate it. It simply lets power come in and lets that same power go out. I can use my amp probe by grounding to the side of the unit. I touch that flue, she's a little warm. I can ground to the side of the unit, and then I can check to verify that I got power coming in. Looking at my amp probe, I got 26 volts. Then, if I check the lead going out, I see that I still have 25 volts, but my ground is just grounded to the unit because this is power in and that same power out. But if I were to look at my gas valve and I wanted to verify whether my gas valve was working, unfortunately, the way it's connected, I can't get my lead down in there in order to test it while it's running. But if, for instance, I'm going to cut the power off on the gas valve for a moment, I'm going to cut the power off. That shut the gas off because I turned it off, but it'll allow the fan to keep running so it can cool the unit down before I shut it off. Now, if I had a problem or a suspected problem with my gas valve, I would pull these wires, both of them off. I pull both of them off, okay? Then I would take my amp probe and I'd run the red into one side and I'd run the black into the other side because I'm trying to verify, does my gas valve work? This is not power in and power out. The gas valve is a device. It has a 24 volt coil inside of it, and it takes 24 volts in order for that gas valve to activate. So I'm going to turn the gas valve back on, okay? We're going to turn it back on. Now, it's going to take a moment, and then the system will go back into its heat cycle. Now, if I watch my amp probe, when the glow plug, or on here, it's not a glow plug, it's a spark igniter. But when the spark igniter begins to flicker, you'll hear it, click, 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 click. And at that point, when you look at the amp probe, you'll see 24 volts going to the gas valve in order to energize it. There's the 24 volts. Well, in this case, 27. Same difference. That sent power to my gas valve. So if my gas valve was not energizing, I just verified that the circuit board sent power to the gas valve. So now if it didn't fire, it must be bad. Those are different things you can use your multimeter for. As we go around, I'm going to show you in different videos. Now my unit, it went through the cycle once. It just went through the cycle again. Spark igniter, it's going through the cycle a third time. The spark igniter will energize. You'll hear it clicking, and then you'll see it sends 24 volts to the circuit board. To the gas valve. When you hear the click, that simulates the circuit board sending power to the spark igniter, and then send power to the gas valve so the gas valve can energize and light. It's tried 3 times. Okay, it's trying a 4th time. Apparently, I interrupted the power in between one of them. Typically, it will try to fire 3 times. And if it does not ignite on the 3rd effort, it'll lock itself out, and the LED light that we were talking about earlier will begin to flash a error code. Again, I don't like getting on my knees and looking at that light, so I will use my knowledge of the furnace to determine what the problem is by simply turning it off, turning it back on, and watching it go through its cycle. And as it goes through its cycle, because I know the process, I can determine where the problem is. We're going to continue with understanding the tools that we use and how to use them in next class. I look forward to seeing you guys.